Hello everyone, I am Piyush Wairale. So in this video we are going to discuss question number 27 of GATE DA26 exam, and this question was asked for simple 1 mark here, right? Now see, this question is based on the calculus subject, right? Very important, right? And we have solved this type of question in our test series as well. Almost every mock test is having a question of this particular type here, right? So let's read the question carefully. Let f of x equals to x cube minus 3x square plus 2. A function is given to us defined on minus 1 to 3 here. So see, here we have the open bracket. It means what? Minus 1 is not included. Here we have the closed bracket. It means what? We have to consider this particular 3 here. It's a boundary condition here. So 3 is included here. So function is defined at x equals to 3. So we can write this as like this: minus 1 less than x less than equals to 3 here, like this. Okay. So this is basically a domain of this particular function given to us. Minus 1 is less than x less than equals to 3 here, like that. Okay. Now which of the following statement are correct? Now see, here we have 4 options. F of x has exactly 2 roots. B option, f of x has minimum at 2 only. F of x has maximum at 0 only. D is basically what? F of x has a root at 1. So option A and D deals with the root of the f of x. Option B and C deals with the what? Maxima and minima here. Okay. So let's first discuss about maxima and minima. So we have the function f of x, right? X cube minus 3x square plus 2 here, right? So what we need to do to find out the maxima and minima? First we have to take the derivative of f of x. That is f dash of x is basically a what? 3x square minus 6x. Now we have to find out the turning point here, right? That is basically a what? F of dash x equals to 0. So we have to equate this to 0. Now here 3x square minus 6x equals to 0. We can take x common. 3x minus 2 equals to 0. That is basically what? X equals to 0 or x equals to 2 here. Okay. So here we got the points. Now what we have to do? We have to again differentiate this particular function. So second derivative of f dash of x, f of x is basically a what? 6x minus 6. Now what we have to do? Whatever the root we got of f dash of x, we have to put in f double dash of x. If f double dash of a is less than 0, that is basically negative, then we can say we are having a maxima at x equals to a. If f double dash of a is greater than 0, it means what? We are going to have a minima at x equals to a. So let's try to find out f double dash of 0 here. So what we got? Minus 6. It means what? We are going to have maxima at x equals to 0. What about f double dash of 2? 12 minus 6 is basically 6. It means what? We are going to have minima at x equals to 2 here. Right? Simple concept of maxima and minima. You need to follow this particular process in each and every question when we are dealing with the maxima and minima here. Okay. Now one thing, whatever the value we got, maxima and minima, it is basically a what? Local maxima. Local maxima. Here we have a local minima because the function is defined for minus 1 less than x less than equal to 3 here. So we have to check for the boundary condition as well. Okay. So first let's try to find out the value of f of x at x equal to 0 and 2. So first maximum value f of 0 is basically a what? We got 0 minus 0 plus 2 is basically a 2. Minimum value f of 2 is basically a what? 8 minus 3 4s are 12 plus 2, that is basically a minus 2. So maximum value is 2, minimum value is minus 2. So as of now it's a local maxima and minimum value. Now we have to find out the f of x value at boundary point as well. That is basically f of 3. So that will be our 3 square will be our 27 minus 3 into 9 plus 2. What we got 2 here. If you observe, we got the maximum value of f of x at x equals to 0 as well as f of 3, you can see. So we have the maximum value. We have maximum at x equals to 0 and 2 here. What about minimum? Here we have f of 2 is basically minus 2. But if you look at it, it is a open interval. So minus 1 we don't have to consider. So whatever the option given to us, f of x has a minimum at x equals to 2 only? Yes, only is the thing, right? So we have f of x has a minimum at 2, that is basically correct here. What about C? F of x has maximum value at 0 only is not the case here. We have a maximum value at 0 and 2 also. So option C is not correct. Most of the students have done mistake here. Only point, they forgot to consider the boundary condition. They have done entire process correctly. They got maximum and minimum value, but they forgot the boundary condition here, right? And please be careful about this only keyword. When we say only, when we say exactly, right? So in the GATE exam, try to pay more attention whenever they are using only or exactly kind of keyword here. Okay, so we can see only is not the correct thing in the case of option number C. So option C is not correct, option B is correct. I hope you understand this particular thing about maxima and minima. Simple process. We just need to consider the boundary point here. You can check out my video based on the maxima and minima. In that I have discussed about the concept of local and global maxima and minima as well. You can just refer to that particular video. That's it. Okay. Now next part is basically to find out the root of this equation. So what is equation given to us? X cube minus 3x square. So here we have f of x, x cube minus 3x square plus 2, right? Yes. So what is the first option? So first option, f of x has exactly 2 roots in this particular interval. And what about option number D? F of x has a root at 1. So how to check if x equals to a is the root of this particular function or not? So what we have to do? Simply take the value of x equals to a. So if f of a is equals to 0, it means to what? A is basically a root of this particular function here. Okay. So option D is basically what? A equals to 1. So let's try to find out the value of f of 1. If it is equals to 0, it means what? It is the root of the equation here. So 1 minus 3 into 1 plus 2. So we got 3 minus 3 is basically a 0. It means what? F of x is having a root at x equals to 1. So option D is correct here. Option B is correct. C is not correct. Option D is correct. So f of x has a root at 1. Simple one here, right? Now what about option number A? F of x has exactly 2 roots in this particular interval. Let's see how to solve this particular case. We have the interval minus 0.920. And we know that x equals to 1 is basically one of the root of f of x. And you can see the highest power is basically 3. So this function is having a 3 roots here. One of the root is basically here what? X equals to 1, right? So there are 2 ways to find out the correct answer for option number A. Either you can find out the root of f of x and see whether it's lying in this particular range or not. How we can do that? So I can divide this f of x. I can divide this f of x by x minus 1 because I know it is the root of the f of x. And if you do that, what we are going to get? So f of x will be a what? X minus 1, and this will be a what? X square minus 2x. That will be a minus 2x, and here plus 2 minus 2 here, like that. So like this. So yeah, so this is correct. F of x, I can write this as like this because x equals to 1 is the root of the equation here. Now I need to find out the root for this particular one. Simple, how to do that? So we know that to find out the roots of the equation, what we have to consider? X equals to a what? Minus b plus minus under root of b square minus 4ac divided by 2a. You can compare with this ax square plus bx plus c here, right? So value of a is basically 1, value of b is basically minus 2, value of c is basically a what? Minus 2 here, right? So you can find out the roots here as well. So minus b is basically a what? We have minus 2, so minus minus will get plus 2, plus minus is basically what we are going to get? B square is basically 4, minus a is basically 1, so c is basically minus 2. So 4 into 2 is basically what? 8 here, right? So plus 8 divided by 2. So what we are going to get? I can take 2. I can simplify this one. That is basically 12 divided by 2. So that is basically what? So 2 plus minus 4 into 3 divided by 2. I can take 2 outside, 2 will get cancelled. That will be what? 1 plus minus under root of 3 here. Right? So we got the two roots here. X1 is basically what? 1 plus under root of 3. And here we have x2 is basically 1 minus under root of 3. We already have a third root that is basically equals to 1. So root 3 is basically 1.732. So that is basically 2.7 something. Here we have 1 minus 1.732. So approximately 0.7 we can say here. Right? So minus 0.7. Right? And here we have 1. So if you observe, x equals to 1, x equals to 2.7, x equals to minus 0.7 are the roots of the f of x here. And if you observe in this particular range, minus 0.7 is lying in this range. So f of x is having exactly one root here. But if you look at the statement here, f of x has exactly two roots. No, that is not correct. We just have one root in this particular range. So option A is not correct. Only option B and D are correct in this particular options, right? So I hope you understand what we have discussed here. We have just find out the root of this f of x. That's it. Okay. So first we already know x equals to 1 is basically root of the f of x. Then we have find out this one. We can write it at like this. And we have just find out the root of this particular remaining portion here. Right? Like this. But here if you observe, we have x cube here. So we can follow this particular method that is correct here. We can find out the root and then we can try to map with the given interval. But what if we have x to the power 6 like that of thing in this f of x? In that case, we cannot find out all the 6 roots here, right? So what to do in such scenario, right? So see, if you understand the concept of roots here, so if I am drawing this x-axis and y-axis, so we have f of x, here we have x, right? Now if you observe, we have this interval minus 0.9 to 0. So f of minus 0.9 is basically what? If you observe, we got 0.9 cube is basically a minus 0.729 minus 3 into 0.9 square is 0.81 into 3 is basically 2.4 something, right? So 2.4 something plus 2. Now if you observe what we are getting here, so minus 2.4 minus 0.7 is basically 3.1 something plus 2. So we are going to get minus 1 point something answer here. That is basically negative. If you calculate f of 0 here, what we are getting 2 here, right? So if I go from minus 0.9 to 0 here, f of x is changing its value from negative to positive. It means what? This particular f of x is crossing the x-axis here. Okay, not to the origin because we don't know. So let me remove this. So this f of x is crossing the x-axis here at this particular point. Okay, then we can say at x equals to a, for example, it's the root of the f of x here, right? Now see, here we got negative value, let's say for example minus 1.1. Here we got the positive value at 2 here. Means within this particular range, the function has changed the value from negative to positive. It means what? At least one, this particular equation has crossed the x-axis. This is what we can say. So from this only I can say it is having at least one root. At least one root for sure. Because there might be possibility that this function goes like this, like this, like this, and then it reaches the point here. So from negative to positive, right? So this is also possible that this particular function has crossed the x-axis multiple times. So that is what we have to check here. Because for this, in this particular range, we are changing the value from negative to positive. It means what? It is going to cross the x-axis. It means what? At least one root is there. So at least one root we can confirm. Right? Let's say for example, here we also got the positive value. Here we also got the positive value. It means what? In this particular range, there is no root for this f of x here. Because it is not crossing the x-axis. Right? I hope you understand this particular point. Now at least one root exists, that is for sure. Now what about the second criteria here? We have to check for the exactly two roots here. How we can do that? Now you can see this scenario. There is a possibility that f of x can go like this, then go down and then again cross like this. It can cross multiple times. But how this will happen? It has to increase, then decrease, then again increase like this. Okay. So can we check whether this function is increasing or decreasing in this particular interval? Let's try to find out that. So how we can do that? I can find out the slope of f of x. how to find out the slope here? Simply f dash of x, right? That is basically slope of function here. So that is equals to 3x square minus 6x. After simplifying, it will be 2x into x minus 2, right? Now what about this f dash of x? What you can observe from this particular thing? Now we have this particular range minus 0.9. So minus 0.9 to 0. So if I put f dash of 0 here, what we are getting? A 0 value here. If I put f dash of what? Minus 0.9. So this will be around minus. So minus 0.9 minus 2 will be again a negative here. So minus minus will become a positive, right? So it will be like this, 2 into minus 0.9. So minus 0.9 minus 2. So minus 2.9 into again into minus will be a positive here, right? Now if you observe f dash of x, right? So this will be positive only. In this entire range, this will be positive only, right? It's an increasing function. So we can say this f dash of, so we can say f of x in this particular range is increasing. Okay, increasing function here. It means what? This will cross the x-axis exactly once. So now I can confirm that, okay, so f of x has exactly one roots here, not two. So option A anyway not correct. Either you can follow this particular approach, you can find out the roots. But what if we have x to the power 6? In that case, you can follow this particular approach here. First, take the derivative, find out the slope and put the intervals here. If you are getting the positive value, that is increasing function. If you get negative value, that is a decreasing function here, like this. Okay. So I hope you understand what we have discussed in this particular video. So I have discussed this increasing function, decreasing function, maxima and minima in detail in my course. You can just refer to that. Okay. So that's it from my side. Thank you.